Hi. Actually, I'm Joey, and I've been working with Tony, Ling, and Xiaoling, and on this project. I might need their help during the Q&A sessions. And so we have been working on the feature selection in text hierarchical classification, and we want to adopt our methods and the applications in China's group buying dataset. Firstly, we're going to talk about something about text characterization. Actually, text characterization assigns like a pre-trained categories to any kind of text document. It is a very effective way for the online information retrieval. And it has a very wide applications. So the online group buying data is actually one of the possible applications. For example, we have a group buying data, and we want to assign, given the information from this text, and we want to assign this text into like a certain group, and which can make it convenient for like further analysis. And there are some challenges actually relating to this problem. The first is the hierarchical and the graphical structure that is involved in the context of hierarchical classification. And one example is that one key issue is that since there are normally a lot of classes, so the imbalance between data set is it happens a lot during the classification. And second is the high dimensional that is involved in this problem. For example, for arbitrary kind of text information, we have a lot. The dimensionality could be very large, so even like larger than 10,000 dimensions. That can make our choice of classifier a little bit challenging. And another issue is the sparsity. That is also relating to the text mining stuff. And since the text we are targeting is not, it's only a kind of text that describes the kind of behavior. It's not very long, and the different text has some overlaps, but not like a lot of overlaps. So the sparsity will be an issue. And so here I propose some of the methodologies that we're going to use in this work, which includes some previous work and also some methods that we are thinking that we can contribute. In this work, we're basically focused on the feature selection part, but for the hierarchical classification part, we borrow some previous work. And there are kind of three basic methods. The first is a global methods. So we target for the target function would be the cost. That includes all the nodes in the classification. And we run a single optimization problems for that target function, which is basically very time consuming. And another way is to do a flat or top down. This way we can do parallel computing for each of the nodes separately. And this is a pretty simple and straightforward way, but it's the between class correlation information is lost. And the third way is the modified of the second method, which is called the bottom-up method. So we put the between class correlations into consideration, and in the form of we bring some like a cost function during our training. So basically we use these three hierarchical classification methods, and for the feature selection. So normally speaking, in the field of hierarchical classification, so the literature in that field does not pay much attention to the feature selection. They just provide some their hierarchical classification methods, and they basically use all the features, and it's just maybe they compare their results. and also we also find some feature selection papers. And actually, I mean, these two topics are quite separate. So we want to see whether the feature selections methods we're focusing on can contribute to the hierarchical classification methods, and whether they can overcome those challenges that arises in the classification, the hierarchical classification. And so we focus on three feature selection methods. The first is the L1 norm regularization method, which is pretty straightforward, like a lasso where like a L1 norm penalized logistic regression. And the second one is also pretty straightforward. That is borrow the idea from PCA and PLS. We use the sparse PCA or PLS for direct dimensionality reduction. And also we want to since SVM is a pretty popular classifier in current researchers, we want to find an adaptive way that can be used in the SVM. So basically, there are wrapper methods rather than like we can do like pre-processing. And the sparsity issues is we haven't covered that in our current study. We can talk about that maybe in the future. And now let me just briefly introduce the data structure, the data set we use. And actually, we use the group binding data in China. And basically, we borrow, we get the data from the three most popular data set, the website from China. And the data covers some time span, and also the data comes from different 32 cities, from large cities to like small towns. And basically, in the science, it's around 100 million. It's more than 100,000. And the features, actually, we haven't looked at it in detail, but the features, based on estimation, the features should be larger than 10,000. And the categories would be just shown here. And right now, we have only done a preliminary study on the 4 cities data. It's only like a 1,600 data set, and with 4,000 features. And we're only considering like 18 categories involved. And here are some of the results. And before that, I'll introduce some of the evaluation methods. And actually, we divide the data set into 70% of the data we choose to be training set, and the other to be testing set. And we use different evaluation methods. For the sake of a hierarchical classification, we can do like overall loss. For example, we choose for arbitrary task data, we just do classification on each of the hierarchical structure, and I mean, this item is viewed to be correct only if it is correct in every node. And also, we can consider structural loss. So basically, we consider the loss, the number of incorrect predictions for considering each node. So basically, that's a little bit more like optimal than the first one. And also, we consider the leaf node loss, which only considers the loss on the leaf nodes, the lower level nodes. And also, there is the precision and recall, which measures the false positive or the true positive rate. And so here are some like preliminary study results. And for the first one is shown for the lasso-based method, and also the L1 logistic regression. And we use the top-down hierarchical structure. And you can see that basically actually we haven't compared our results with the current like other methods, but I think that's basically this result is pretty promising before we do any kind of parameter tuning. So hopefully we'll just focus on that in the future. And also we do a little bit on the SVM-based method, and also we do some like a test on the sparse generalized PLS model. And we haven't like systematically group our data, group our results, but based on the preliminary study, our results are kind of acceptable, and especially acceptable for a future study. Another thing that I need to point out here is that the preliminary study, the preliminary data set is only, the N is actually only 1,600, so that might be a problem. That might not be a problem for SBM, but it could be a problem for SBM if we use the whole data set. So here are some future tasks that I have mentioned some during my introduction to our current work. Yeah. I think the realization of our methods in a very advanced bottom-up hierarchical classifier, and also the systematic evaluation comparison with the commercial methods are kind of our interest. Yeah.
Thank you.